So, welcome and good afternoon to everyone. I'm happy to give you an update on our loopamid product and project from BASF. My name is Dag Wiebelhaus, and at BASF I'm leading the activities around our recycled polyamide 6 loopamid. When I was preparing for this presentation, I was thinking, what would you like to know? After last year also, a colleague of mine, Frank, was giving an introduction. And since then we had many customer discussions, and they were always sort of typical questions. They came up every time we presented and discussed loopamid. And I thought I would answer one of those typical questions per slide, and so at the end of the presentation you have quite a good overview of where we stand and what loopamid actually represents. So let me start off with the first very basic slide. What actually is loopamid? Don't know whether everyone knows what it is. Loopamid is actually our BASF brand name for a recycled polyamide 6 that is made entirely out of textile waste, and with the emphasis on entirely. So everything that you buy here has been textile waste. Yeah, when we started off this 5 years ago, people have always been asking why is actually BASF developing this new product, and there are of course many reasons when we started this, but maybe the three main ones I have highlighted here on this slide. 5 years ago, we started this endeavor, and at that time it was already clear that the market is demanding for more sustainable fiber materials for textiles. There was a growing demand for sustainable fashion, especially in Europe, but also around the world. And this was supported and is supported by regulation. So legislation is kicking in to actually support this market need. And you see that especially in Europe. With the Green Deal 5 years ago, we were very enthusiastic about all the new regulations that would support such a project. And some of them are coming into force now. You know that in Europe we have now mandatory collection of textile waste actually since the 1st of January this year, and there are more legislation coming on. When we started this, we actually had thought it would all move a little bit faster, but I think the trend is still clearly there, but maybe a little slower than we thought 5 years ago. Okay, then the last topic that you see also now in the new legislation that is discussed, at least in the EU legislation, will favor closed loop solutions. So it's not only about recycling, but it's also the question, what do we recycle? And there's a preference clearly, and I think that makes a lot of sense, to recycle the waste within each industry. So you do textile to textile, and you do bottle to bottle, and you do packaging to packaging, instead of bottle to textiles, and then very often there's a dead end. If you do it in the same industry, you can actually then do infinite circles, and that has a charm, of course. So what makes our product loopamid unique? And as I said here in the drivers when we started this off, our ambition from the very beginning was that we wanted to develop a closed loop solution. So really wanted to use only textile waste to create a polyamide that is then again used in textiles, and so on and so on. And in order to be able to do that, you need a very special technology to actually recycle this very complex waste. Textile waste is a complex raw material, and therefore we as a chemical company started off to develop this molecular recycling technology that will come up in a minute. The other thing that is unique, if you compare us to other recycling solutions out in the market, is that our product is coming out of a segregated production. That's maybe a special term that not everyone knows, but it means that actually your production does only produce your recycled material, nothing else, and you don't need a mass balance. There are many other solutions out there, recycled product, that require mass balancing. You actually have only a small share of recycled material in a big pile of something else, and then you allocate your recycled volumes. And the advantage of this segregated production that we are doing is that our customers can actually make the best claims. They can make what we call content claims. So you can claim this jacket, for example, is made out of textile waste. If you do a mass balanced product, you cannot do that. You can do other claims. There are a lot of other claims, but content claims are only possible if you have a segregated production. And then last but not least, of course, from the very beginning, the target was to develop a more sustainable solution with a lower environmental footprint, and the CO2 reduction that our technology brings lies in the order of 70% compared to the virgin polyamide 6. And there's room for further improvements, actually. So, I told you that loopamid is unique, mainly also due to its technology that is unique. If you want to recycle textile waste, you need technology that is really very robust. Textile waste is a complex mixture with a lot of impurities, and to recycle textile waste is so much more difficult than to recycle fish nets or carpets or bottles. So if you have a very pure raw material, recycling is actually not so difficult. Still difficult, but not that difficult. If you want to recycle a very complex material like textile waste, then your process needs to be very robust to continuously digest that raw material. And I've brought you here several examples of things that you find in textile waste that people don't want when it's recycled, and that actually hinders a lot of processes that competitors are using. So coatings, laminations, dyes, I think this is very understandable. A lot of processes do have problems with spandex. Spandex, also called elastane. So each time you have a very stretchy fabric, it contains usually elastane, and that is actually very difficult for many processes to cope with, and therefore other processes require that purities of the raw material are very high. And then one other thing that that I think is on everyone's mind is PFAS. So of course a lot of the waste that is collected today does contain still PFAS in it. And there's also the question, does the process tolerate that, and can you remove it? And the answer is yes. In our case, it's not a problem for us. And at the end of the process, our loopamid does not contain any fluorine-containing compounds anymore. And then, last but not least, but that was the target from the very beginning, our recycled polyamide 6, the loopamid, is exactly as virgin material. So between a fossil-based polyamide 6 and our loopamid, you will not see any difference. Now, how does our process actually work? I told you I'm from BASF. We do chemistry. What we do is a molecular recycling process, also, of course, called chemical recycling. I don't use the term chemical recycling so often, or don't like it too much, although me as a chemist, of course, I like that. But people then think you do a lot of chemistry, you add chemicals. But that's actually not what we are doing. We are using almost no added chemicals. The process as such is a chemical process in that it's a molecular process where you deconstruct your polymeric structure on a molecular level. You regenerate the individual building blocks that we call monomers as a chemist. And then these building blocks, they are purified. This is the crucial step where you get rid of all the impurities. And then once you have your purified building block, you can then, on a molecular level, build up again your chain for the polymer. And then you're back exactly where you started off with. Without chemistry, but with a molecular structure change. So it's a sort of a deconstruction and reconstruction. And in between, we do a lot of purification. And that's really the difference compared to other processes, like for example, mechanical recycling. There you have difficulties in removing impurities, and the properties of your final product is different from your original product. In our process, because we deconstruct and then reconstruct, after the reconstruction, the material is really exactly the same as the virgin material. And therefore, we can really say we are closing the loop. Because if you want to close the loop, at the end of the loop, you really need to end exactly at the same position where you started off. If you do that, then you can do circles over and over and over again. If you end up slightly beneath the point where you started, then it starts to get off track, and therefore you usually then only do 1 or 2 cycles, and then it's dead end. Our process can be done over and over and over again. And you also see here on the slide that we're currently scaling up. We have material out of a continuous process now that is already tested in spinning. Our customers are producing yarns, and our ambition as the suppliers of loopamid is that the yarn producer does not see any difference whether he uses loopamid or if he or she uses normal polyamide 6. It's exactly the same. You will see no difference. Okay, I've told you now a lot about what loopamid is and the technology behind it. I want to now focus on one topic that is really crucial in recycling. I touched on that already before, and that's the raw material. For us as a chemical company, it's really something unusual that the raw material is not well defined. Waste is not well defined. Every textile waste looks a little different, and we are using different textile sources. And therefore, I want to explain you a little bit more what we are using. And before I explain you some more details, I have a short video to show to you. Okay, we've developed this video to show, you can also find it on our loopamid website, to show you a little bit more background where our raw materials come from. We are using exclusively textile waste, nothing else. And as I said, this was from the very beginning the target, that at the end we recycle especially post-consumer textile waste. Now, we are using actually 2 sources. Post-consumer waste is what you really, if your garment is not giving any use anymore and you throw it away, this is the post-consumer waste. This is actually the most difficult, and this is what we can do and what we strive to do. But it has its limitations, not in the process, but in its availability. I come to that on the next slide. Therefore, here I want to explain you that as a second raw material to actually fill the plant and deliver enough material, we are also using post-industrial waste. And I want to emphasize that we target exclusively textile waste from post-industrial sources that are really waste. So the sole product that we are targeting, the sole feedstock source, in this case for the post-industrial, is what is called cutting waste or cutting table waste. So this is really on the final step of making a garment. The fabric then already has every things that I explained before that are difficult to recycle. So of course it's already dyed, it has additives, it has titanium dioxide, it has maybe coatings, it is maybe already mixed with elastane. So everything that the final garment also has, apart from, of course, dirt and sweat that come later, but from a chemical standpoint, everything's already there. And therefore, this cutting waste today is really waste. Almost all of that is either incinerated or landfilled because it's really, there's no use for it. And it's a huge amount. On average, the industry counts that about 15% waste is generated on this last step, because this cutting out of the large fabric pieces is just not easy. Yeah, you cut out your garment pieces, and if you have a normal fabric, there are pieces left over. On average, 15%. The textile industry uses about 100 million tons of material every year. So 15% is 15 million tons of cutting waste that today is, as I said, mostly incinerated or landfilled. So that is one waste that we are also processing, and also there, if it has like 15% spandex, not a problem for us, difficult for many others. And let me focus a little bit on the post-consumer waste. This is really the waste that we would love to use, because this is really the worst waste. Most people can't use it, and our process can use it. But the availability of that waste is very, very limited today. And why that is the case, I tried to explain on this slide. There's actually a very long and tedious process to separate the waste that we can use. So today, post-consumer waste is collected, as I said, since the 1st of January this year, mandatory in all EU member states to collect textile waste separately. And then after that, most of the sorting is done manually today. Almost all of it is done. But today it's mainly sorted for reuse and for other uses like downcycling, but it's not really sorted yet by fiber type. What we need for recycling, a true textile-to-textile recycling, you need to separate by type of material. So you have then later a pile of cotton, of polyester, of polyamide, of wool, and so on. And then you can do recycling. And this step is actually under development. Today, the technology as such is mostly developed. You can do that. As you see here, the technology is mainly using infrared spectroscopy to distinguish the different chemical structures, so the different fiber types. It could be implemented, but as of today, the infrastructure just doesn't exist. Even in Europe, virtually no fully automated plants are available. So everything is done manually, and therefore the amount of sorted textile waste from post-consumer is almost zero. That's maybe an exaggeration, but very little. A few percent maybe. All the rest today is not sorted yet. We are actually collaborating with many sorters in Europe, but also in Asia. As I said, the technology is there, but it needs scale. We are working with several to fill our facility. But as of today, volumes are small, and therefore for our loopamid, as we are now scaling, initially the source will be post-industrial, and as post-consumer material becomes available, we will increase the share of post-consumer until eventually it will be 100%. But it will be a journey, really, to sort hundreds and thousands of tons of waste into separate fiber type fractions is something that unfortunately will take years. And as I said at the very beginning, when we started off our journey 5 years ago, we thought when in Europe there is a mandate to collect waste, textile waste separately, something needs to do with it. So probably the collection sorting infrastructure will be set up until then. But actually that has not happened. The mandate is there, but today the technology, the infrastructure to sort the material is not there. So it will take a couple of years more, but it will come, both in Europe as well as the rest of the world. Okay, that was a very long explanation, but I thought this is really important because people want post-consumer recycled material, and we can deliver it, but the feedstock currently is not available on sufficient scale. Okay, speaking about scaling, where do we stand with scaling now our loopamid? Some of you might know that last year we actually launched the first capsule collection based on loopamid together with our partner Zara. This jacket came out early last year and was sold out on their website within hours. And this beautiful jacket, you can visit it at our booth. And this here at the other end of the hall, we have our booth. You can see one of the jackets. This jacket is unique in actually two respects. First of all, of course, it's made from loopamid, the first garment from loopamid, therefore it's unique. But it's also unique because this jacket actually is what we call a one material jacket. So this jacket really consists completely out of loopamid. So not only the fiber as such, the fabric as such, but also the lining, the Velcro tape, the zipper, the fillings, the buttons, everything is made out of loopamid. Loopamid, as I said, is a polyamide 6. Polyamide 6 has the advantage that all those pieces can be made out of polyamide 6, and as it can be made out of polyamide 6, it can also be made out of loopamid, and therefore here, Inditex, the mother company of Zara, and us, we had the ambition to say we want to show that you can produce a complex, not a t-shirt, a complex one material garment out of this one material and say this is 100%, this is entirely made from textile waste. And in that case, actually, it was from post-consumer that was collected in containers in Spain by the company Modare. And we had a lot of partners, as you see here, because it was a complex endeavor, and for each of the different components, we had leaders in the industry to support us. That jacket was really a small capsule collection, and the loopamid we produced for that was still coming out of a small pilot scale production in Germany. And since we have shown that it's feasible, we have been scaling to the next level. And as we speak this year, you will see more loopamid to come out. Loopamid polymer is now available in larger quantities, in commercial quantities, and we are currently testing it with yarn producers to produce yarns, already successful. Currently, we are on the weaving and knitting step, and we expect that you will see more collections from several brands this year, and everyone that is interested to buy loopamid, we supply the polymer. So you can buy the polymer from us, but of course we can also name you partners for spinning and weaving as we move into 2025 that you can work with to get yarns and fabrics. And with that, I hope I had given you a good overview and also an outlook for this year. And the questions that I did not answer on my slides, I can answer either now, or you come to our booth today or tomorrow, and we are happy to get your questions. Thank you very much. But
first and foremost, can we show our appreciation, please?
Thank you.
Now, if anyone's got any questions, we're happy to answer them now. I'll bring the microphone to you. I normally say I trap them when they come off the stage if you want a quiet one-to-one, but because you have a booth in the innovation area, it's easier to go there. The innovation area was the first area you walked into in this hall. So I'm filling in case anyone wants to stick up their hand and ask the public question. Not yet. Yes, we have one.
Thank you for the presentation. It was very, very interesting. I just want to check if I understood it correctly. So I'm not in the apparel industry, I'm in the accessories, so we do backpacks. That means that our fabrics, they will always be coated or laminated. If we make a backpack that it's fully made of PAC, laminated with, I don't know, a different, because there's no PAC lamination, PA6 lamination, with a different lamination, can that still be recycled?
Yes. We have not found a single material so far. We've done hundreds of experiments that any material that is not processable for us. Of course, we will only recycle the PA6 content, the polymer 6 content. The lamination, if it's something different, this is not recyclable, but it also doesn't hinder our process. That's very often the problem. So if you bring us a waste that has I don't know, 85% PA6, and the rest is then, I don't know, rubber or polyester or whatever you're using, EPME, then we can process that and recycle the polyamide 6.
And then my next question, is there a limitation in what coating or lamination can be used, or treatment?
You know, as I said, we have tested a lot. I can't say tested everything from a chemical standpoint, that's not feasible, but we are very confident there is no material that will really be a big problem for us.
I don't want to reinforce about what a major step forward this is in recycling technology. It has changed the game completely. And those of you who aren't tuned in, I'm seeing someone else down here, we haven't gone into detail on mass balance. You're using a mass balance approach in several areas. If mass balance is not part of your conversation, it's coming in on recycling really quickly. So Google mass balance, get to learn on mass balance, because all the speakers will be using that language at the next show.
That's correct. As I said before, this product actually does not require mass balance. That's also unique.
Thank you for the presentation. I'm sorry if I missed this maybe, but is the content 100% recycled then in the new polymer, or is it a split?
Yes, it's 100%.
And can I ask a follow-up in terms of the fractions you cannot recycle? What happens to those?
Yeah, the fraction that is not recycled. So let's take an example. We have maybe a typical stretchable garment that has 85% PA6 and 15% elastane, to make it easy. Then actually we separate the two in our process. You will get that back almost all of the 85% as loopamid, and the 15%, unfortunately, is waste, will be incinerated, but the energy will be used in our process to feed, to heat the process. But actually, I think I said at the beginning, we have a reduction in CO2 footprint of about 70%, so minus 70%, remaining 30%. And a large chunk of that is actually this 20% waste that we need to burn. So if you bring us more pure feedstock and we only have like 5% non-recyclable part in there, then the PCF, the product carbon footprint, will be even better. Okay, I don't see any more questions.
Oh, Esther.
Sorry.
Beware of Esther. She knows a bit more than she admits.
Are you doing active take-back programs at this stage from brands?
There are many brands that are interested, yes, and we would be open to do that, because that would be then probably a relatively pure feedstock. We have learned that actually also there the volumes compared to the overall waste volumes are still relatively small. But if that scales, that would be a perfect feedstock. For example, in our jacket, of course, if it comes back, that is 100% polyamide 6. We would love to recycle that again.
There is an extra question.
Thank you. Sorry, I have one more question to the jacket and the trims. Do you have different polymer grades then for the other components beyond the yarn?
No, they are actually all the same.
Okay.
Yeah. We have
Thank
only produced one grade, and that was used for all the components. We could produce slightly different viscosities, if that's what you mean. But for this project, actually all our partners were able to use the same loopamid quality for the different parts.
Thank you.
My pleasure.
Just to add to that, look at the name in the bottom right-hand corner. This is BASF. When they do it properly. This is a massive technologically advanced solution. And we're not yet understanding it because it is that much above what we're used to. It's a magnificent progress. And I'm filling for any questions. In which case, if there are no questions, can I ask you once again to show your thanks for what's on stage?
Thank you very much for your attention.